thank you for taking the trek all the way here and spend the next 50 minutes talking about single sign-out and session in modern times. My name is Vittorio Bertocci. You can hear from my accent, I'm from Seattle, Washington State. Good, we start well. That was the reaction I wanted to get. Sign-out is one of the most neglected things in pretty much all of identity. You typically do your demo, you do your single sign-on, your consent, your second factor, whatever you want to demo. It works, victory lap, is it time for lunch yet? And no one ever really thinks about sign-out. But unfortunately, from a security perspective, sign-out is one of the most important things. In particular, distributed sign-out. And on the best day, sign-out is best effort. It's not a transaction. You don't have any certainty that it worked or not. So it was always a complicated thing. And today, it's much harder than it was. So all of those things compound to put us in a situation which is not great. And soon, we actually won't be able to ignore it, because there are changes coming at the horizon in the way in which browsers behave that will substantially break pretty much almost all of the protocols that are being used today for signing out. Not great. Do I need to shake it? And then do the dramatic gesture. Not a lawyer, no idea what it says. Also not a lawyer, but this is the one from my company. I toyed with learning how to wrap it and say it really, really fast, but then decided not to do it. And also, I'm not going to talk about any products. I'm only talking about protocols, open standards, and trends. So hopefully, whatever legal magic is in there isn't strictly necessary. So this is how I'm going to break down this thing. Also, this is my first 50 minutes slot after COVID. Like all the conferences I've done were always 20 minutes. So 50 minutes is long. This topic is complicated. I'll do my part trying to be animated and keep you alive. But you need to do your part and pay attention. I know it's hard. 50 minutes is hard. So again, I'll try to be as colorful and funny as possible. But the topic is, unfortunately, not very exciting. It's sign out. So first, we are going to refresh and get on the same page on what we mean with sign out. We all think we are experts on sign out because sometime in early 2000, once I signed out from an app. But in fact, devil is in the details for this. The reason for which things will break are in the details. So we will have to dig at the details level. Then we'll take a look at actually the protocols that are in use today, the most popular. We'll look again at the implementation detail, only colorful pictures, no code, don't worry. And we'll see the places where the new changes in the browser will break. Then we'll take a look at the modern techniques. There are ways in which you can sign out today which are not affected by the demise of third-party cookies. However, there are a lot of gotchas, which we will go through. And then finally, we just take a look ahead and what we can do in the next few months to contain the damage. Is there anything else about sign out that anyone want to hear today? This is your chance to tell me, and my chance to include it in the agenda. 3, 2, 1. All right, so this is the a la carte menu. That's what you're going to get. So what does sign out even mean? Here is the definition that I prefer. A session is a period of time during which the user or an app can access a resource without being prompted. That is what a session is. Now, in the common parlance, very often, the artifact which represents the session is often called session. Like saying, here I have this session saved on the server, what does it mean? It's usually one of the pieces that make that behavior possible saved somewhere. So that's also an artifact. And here, there is a concrete example. Normally, as we do sign in for the last decade or couple of decades, you typically have your browser that hits what we call a relying party or a service provider, if you like, SAML, and you try to get a resource, which is protected. The typical reaction is that the resource will craft a message following SAML, OpenID Connect, if you like steampunk, WS Federation, and we'll redirect you with this message to the identity provider, saying, here I have this user, I am application X, please authenticate, and sometimes a bit more context. Here, the identity provider will do whatever is necessary to authenticate the user, typically not specified in the protocol. These could be Kerberos, could be username and password, could be passkeys, whatever it wants. And the outcome of this is two artifacts. One is a cookie that says this user authenticated with the IDP. The other is a token. Depending on the protocol you use, this might be a SAML assertion, it could be an ID token, whatever. And then this token gets sent, the relying party validates this token and decides to create a session of its own. So now we have two sessions. One session with the IDP, one session with the relying party. The one with the relying party is somewhat dependent on the IDP one. So often when we say session, we really mean the IDP one. OK, so now we know what is a session. What is sign out? Sign out is killing a session. It's as simple as that. And here, we already get our first ambiguity. Some people expect you sign out of the app and nothing else. Some people expect the sign out to propagate to the identity provider, so that when I sign out from the app, I also sign out from the identity provider. That's what we are going to assume in here, but that's not at all something that you can expect. Every time you need to ask your customer whether that's what they think. And so what does it look like? You really need to do a gesture, otherwise it doesn't work. So here I have my session. I now go on a page on the relying party and say logout. And that page has the effect to kill my cookie with the relying party. And then I get redirected to the IDP with a message that says, I want to sign out from this session. And in fact, I just present the cookie, which represents the session, and the IDP terminates it. And so now we are back to homeostasis. We are out of everything. Now, finally, we get to what we want, which is a single logout, or single sign out, or various variants. And the idea is that it's the sign out that we have just seen, plus signing out of every relying party you might have signed in as part of the IDP session. So here we are back to being signed in into one relying party and the IDP. And now we want to do single sign-on with a second relying party. So we ask for a protected page, we get redirected to the IDP, and we already have a cookie, which says user is signed in. So user is not presented with any prompt. We get back the token, this time for relying party 2, and now we get a third cookie. So the essence of single sign-on. Hopefully not surprising for anyone. And now we do the sign-out. We start like before, in which we just hit relying party 1 and say, I want to log out. So relying party gets rid of its own cookie, redirects me to the IDP. IDP gets rid of a cookie and does something new. It sends down a page. Here you'll see, once we get to the details of the various protocols, that different protocols do different things. But in general, you'll send something down to the browser, which points to all the other relying parties that you need to sign out from. In particular, here, I have an iframe. And this iframe points to the relying party 2 domain, as such as access to that cookie, which gets sent as part of this, and sends a sign-out message. And so now my relying party 2 gets rid of it, and voila. I'm back to I'm signing out from everywhere. So this is distributed sign-out. Easy enough. Today, unfortunately, things are significantly more complicated. For starters, your IDP is rarely just an IDP. Very often, it's some federation provider, which is an intermediary between your apps and a collection of different identity providers, which might be Active Directories, it could be in social media, it's like Facebook, Twitter, GitHub, whatever. Okay. And the idea is that this thing will also have its own cookie, which is also part of this session, because potentially, if you get rid of all those cookies, but you keep the gold cookie, and now you just attempt to sign in again, the user might sign in back without it being prompted for anything. So it's not something that you can ignore. You need to take that cookie into account. But the thing is, the protocol between IDP and IDP2 is not always known. If you are trying to sign out from a social network, good luck. They are not very keen of your users signing out because now they lose tracking access. And so there is not always a single protocol you can use. And even when there is, there are no guarantees that you log out. And this is kind of like child's play in comparison to more stuff. Today, everything is programmable, so APIs. And you can have APIs accessed from a backend, and that access occurs using tokens, which are other artifacts which are not touched by all the logout flows that I just described. They are just there. And if they are left over when you sign out, then you still have some routes for the application to access resources, which of course is a problem. And making that call from the backend is just one of the many ways we can do this. We can have single-page apps, stuff that runs inside the browser. Instead of doing cookies, it also manages tokens in JavaScript. And once again, we don't have flows that reliably get rid of those tokens when we sign out. And then finally, mobile applications and desktop applications, which also have artifacts for maintaining session, and that also gets out, like they are completely out of the picture. I'm not going to mention these other methods. I'm going to focus on the web browser-based for the rest of the talk. But it's very important to know that those things do exist. And I'll mention them in a couple of other times. OK, so now let's look in more details about the traditional sign-out flows. Today, in main use, you have the OpenID Connect different flavors of sign-out, which I'll go in details, like I'm going to break them down into various flows. Or we have SAML. I'm not going to go into the details of SAML because, one, it's not affected by the third-party cookies issue. And second, because it is crazy that people even does it. Because like, the way in which the most common SAML flow, logout flow works is that when you send something to your relying party and you sign them out, then you expect them to go to the next relying party in the chain and send them the message to sign out. So you can imagine how incredibly brittle this thing is. Like anyone in your flow can interrupt the chain and you're not signing out. So yeah, you're not affected by the third-party cookie issue, but it's like a travesty of a sign out anyway. So I won't go into the details of that. But I will explore the OpenID Connect ones. And here there is, I'd say, probably the most common technique, which is what we call front channel logout. And here I can take a little bit of credit for the existence of this, because the next method that I'll show you is very hard to package in an SDK. And when this stuff was happening, I was working for Microsoft, and I owned the identity SDKs. And I was very unhappy with that. And so like, I just pulled the jacket of the people doing this, like, come on, give me a front channel one. And ta-da, we have a front channel one. So unfortunately, like, this is great. This works great. It will stop working in just a few months. But it was a good ride. For a few years, we had a good method, which I was able to package in an SDK. And this is very similar to what we did earlier, but I'm just zooming stuff out so that you can see important details, like the domains. So here I am signed in both relying party 1 and relying party 2. I have all my cookies, and the cookie, which is for the IDP, contains information about all the relying parties that got their session thanks to that first session. So what happens is that I sign out from the first one, and so that's it. Then I actually go back to the IDP, see that now the domain that I have in there on the browser is the IDP. And now I just get rid of my own cookie, and I also receive my cookie with the list of all the relying parties that I need to sign out from. Now, the first one is the origin of a sign out message, so I don't need to play with it. But the second one is actually the one where I need to sign out. And so I set an iframe which points to the relying party 2 domain, which gives me access to its own cookie. And then this cookie, which represents the session, is part of my request to RP2, and RP2 just deletes it, and so I sign it out, just like before. Now, what is the problem here? The problem is that browsers decided that the third-party cookies, which is exactly the scenario that I just described here, are not a good thing. Like, we define a third-party cookie as a cookie which is accessed, which belongs to a domain which is different from the one that is in the top level of the page. So in the main address, you can see that we are pointing to IDP, but our iframe is pointing at RP2. So as such, for this particular page, this cookie is a third-party cookie. If a top address would be RP2, now it would be a first-party cookie. Now, why are browsers killing third-party cookies? Mostly because they are a primitive, which is the fundamental block of unsanctioned tracking. Like when advertisers wanted to follow you through the internet and discover your preferences and create a dossier on you, they typically do this. This is like the classic pixel that Facebook was used to place on pages, in which you'd have like one pixel on that idp.com page, and the source image of that pixel was facebook.com. And basically, the sheer fact that your page would make a request to facebook.com would carry all the context of where you were, the top level, where you have been in the former redirect, everything. And so basically, I don't want to pick on Facebook. Like, pretty much every advertiser did this. And unfortunately, given that this is not a great thing, like we don't like people being tracked, the browsers just started saying, you know what? Your cookies cannot be accessed from an iframe or from an image tag when you are not on your own domain. And this successfully stops tracking. But guess what else it successfully stops? Come on, this one is easy. You have literally on the page right now. It stops these kind of flows. Because if now, when I open that iframe to hit RP2 to log out, I don't attach to my request that cookie, RP2 will have absolutely no idea of what session I'm talking about. Like RP2 will have, hopefully for them, multiple concurrent sessions. And there are tricks you can try to use, like sending a hint of a username, all these kind of things, but they are all not very good. Like, you don't want bad guys to sign you out just by knowing your username, right? So, complication. This flow already today, if you use Safari, doesn't work. And today the answer is, well, download Chrome and use Chrome. But Chrome wanted to kill those cookies for a long while, and they only slowed down because of COVID, and they knew that everyone needed to access stuff from home, and so they didn't want to disrupt a lot of flows, but it's planned. Like, I think that before the summer, they'll actually kill third-party cookies. So this method will stop working. Now, luckily, there is another method which will also stop working, but never mind. This method is called session management. And it is a method that works very well for single-page apps, things that execute mostly on the client side. And the idea is every relying party in every single page always carries one iframe that points to the IDP domain. And basically, there are HTML5 APIs you can use to inspect whether a particular cookie is present or not in that particular domain. So basically, both RP1 and RP2 can always look inside those frames that they host and verify whether there is still a session with the IDP. This is the part which was very hard to package in SDKs that led me to try to push for the other stuff. And so what happens is that relying party 2 tries to get to relying party 1 tries to sign out, signs out as usual, redirects to the IDP, and the IDP signs out, and as a result, all the cookies from every frames are gone. And so now, RP1 already knew because it was the originator of a sign out, but RP2 just detects that this thing happened, and so it can proactively sign out. Can anyone tell me what is the problem with this flow? Is anyone here with me? If you are in the room, flicker the lights. Say again?
What
if you don't want to log out from, well, so the comment is, what if I don't want to log out from RP2? And the answer is, you can decide not to react to the thing and stay in there, but that is not a problem. It's just like a decision in there. So given that you don't collaborate, I love to tell you, the problem is, once again, that that is a case of a third-party cookie in a frame, which has a different domain than the top-level domain. So this thing will also stop working. So not good, not great. So single-page apps, again, like the method that I just described in here works with single-page apps because the JavaScript is the thing that will be aware of what happens. But unfortunately, these will break. And also, all of these, once again, only deals with cookies and web browsers. It doesn't do anything with tokens. Like, just like you can take the cookies from your relying parties as dependent on the main IDP session, you can think of the tokens that you obtained in an app as dependent on the session of the app in itself. And today, we don't have any protocol, any standard that say what to do with those tokens. It's largely left to every vendor. And every vendor does something different. We all try to do the right thing, but without a standard, usually the right thing is different for everyone. And there are some efforts for trying to fix this, but early on, still underway. Once again, signing out is one of those things which is not perceived as urgent, which is unfortunate because we keep telling us, assume breach, but then if we don't have a control plane for example, reacting to the breach, then it's a problem. Okay, so this is what we use today. Let's see what we can do in this brave new world and see if we can actually avoid the third-party cookie curse. First, a few tricks. One big trick you can use in here is to use CNAMEs. You can use custom domains. So if I rewind a bit, the little noise is very video gamey. At home, it wasn't doing the noise, I promise. So if we get back in here, and you see that you have idp.com, top level, rp2.com as a browser. Now, what if I use the CNAME and I change the DNS so that my RP2 is IDP as well? So at this point, if I have the same domain across those two, then the cookie is no longer a third-party cookie. And so now the cookie will be accessible by that browser as well. Neat trick with two big issues. One issue is that typically you will have a large collection of relying parties. And this thing only works for one domain. You can only make two domains the same. If you have extra domains, they will always be out. And if you have a lot of properties, you don't know from where the logout is going to start. So you can't use these in a lot of situations. The other is that some providers think that this is a potential abuse. Like Apple in particular thinks that people might use these for tricking users into being tracked. And no amount of telling them, but the developer needs to be on board with doing this behavior, the very reaction is like, well, I care about the users, not about the developer. So there's no recourse when they say this. So far, they aren't really doing anything, but I fully expect that some customers using these occasionally on Safari will start seeing this breaking. In particular, the thing they do is, if you do this trick with CNAMEs, they will limit the duration of your cookies to 7 days. And although for enterprise, 7 days is not that bad because users will keep touching stuff, for consumer, it's not great. Like if you own a magazine and you somewhat manage to convince someone to pay a subscription online, which is pretty complicated, and if person doesn't go to your pages for 1 week and the day 8, they cut in there and they have to sign in again, I guarantee that they will be very unhappy. So in terms of security, you're fine, but in terms of user experience, this thing is not great. The other method, which I'm not skipping there because I need this diagram, is what was called first-party sets. First-party sets was a new API suggested by Google, in which substantially you could have every domain publish a little JSON file pointing to all the other domains that it wanted to behave like a single first-party unit. So imagine in this particular scenario, you would have relying party 1 having a file that says idp.com is my friend, and rp2 saying idp.com is my friend. And idp.com would have a file saying rp1 and rp2 are my friends. And the idea was that browsers would have acted on those domains like they are a first party. This was very promising, but unfortunately, both Firefox and Apple and others at W3C didn't like that. They didn't like that because they stated that that went against the spirit of the web, and the users might not be aware that they might be tracked across those domains, which look completely different, and so they pushed back. So now it's unclear where we stand. Like Google, I think, still wants to pursue it, but we don't want to start writing code which does something different depending on the browser. We've been there, early 2000s, wasn't fun, so we'd like to use standards. So also not a very viable option. Fast forward, fast. OK, there's more, but I'll do it in a second. Now, this one is the one I like. This one is an existing standard which has almost no usage because it's hard to use. But at this point, it might actually become very viable. Hence, people are starting to implement it. And this is what we call backchannel logout. The idea is I sign out from relying party 1 as usual. Like I just use the exact same flow as before. And I sign out from the IDP also as usual, exactly the same flow. I just go back in there, and that's it. Now, you might have noticed that I added this little label to the cookies and to the service side. That label is the identifier of a session. It's just something that says, OK, everything under this identifier belongs to the same session. So once I go to my IDP and I say, hey, I'm terminating session as DP1, the IDP gets rid of its own cookie and then does something new. It actually sends server to server, so this doesn't go through the browser, a message to all the remaining relying parties that need to be signed out. And in this message, I have something very similar to an ID token. It doesn't contain any identity information, but it has a strong reference to the subject, who's the user, and the ID of the session. And now what happens? What happens is that the relying party validates this token to make sure that no one is forcing sign out without having the rights to do so, and then takes a note. That is the thing that makes this flow complicated. I need to have a server state on the relying party 2, and I need to save the identifier of that thing. Mostly because this session, this SD1, is somewhere in some browser, but that browser is not with me right now. I just got a server-to-server request. So the next time that the browser shows up in here, it's the equivalent to get into the bank with with your account in the red. You try to use your card, and the guy grabs the card and cut it. Say, sorry, no, this card is no longer good. And here it's the same with a cookie. You show up saying, hey, I'd like your protected resource. This thing says, well, you've been flagged for sign out. And so cuts the cookie, and that's it. So this thing about the server side is what makes this a bit more complicated. The reality is like your experience might vary, but for my customers, most applications already have their state because for the business that they deliver, they need to have some state. So in our SDKs, we just add something that says, tell me where to write stuff, and then we do it on behalf of the developer. So it's not particularly hard. But it's true that if you have like a pure Lambda in which there is no state, you can't use this system. The other challenge with this is if your relying party lives behind a firewall, then the server-to-server call ain't going to work. Because like, typically, your IDP will be in the public internet in the cloud somewhere. And when you use front channel, typically what matters is where your browser is and where your relying party is. So if you have your employees in your local network that use Azure AD, just for not mentioning my own identity provider, OKTA. Basically, what happens is that you are hitting that thing which is in the cloud, but your browser is right there. And so when you go back to, like if you follow a front channel logout, for example, in which you are hitting all the relying parties that are in there from your browser, if your relying party is behind your firewall in your local network, and your employee has the browser in a device in the local network, then no problem, you have line of sight. But in this case, if it's coming from the server, then the logout message might not reach your stuff, which is unfortunate. OK, so you might have heard about this shared signal framework, which is a very powerful thing, which is new. And it's basically an eventing system. It's a way of propagating security salient events, like, for example, this account has been disabled, or this password for this user has been changed. And so there is this framework with messaging, with event sinks, event sources. You could use this for sign out. You could, and you can be even more sophisticated. Like, for example, the change password, you might send this message, and other relying parties might decide, yes, I think that this is an event important enough that I'm going to log out the user. So you can do things a bit more sophisticated than just blaring out logout. The drawback of this is that it is very expensive. It's like it's an eventing system, so you need all the availability, all the addressability, all of that stuff. So if you already have that thing up for other reasons, like continuous authorization, for example, that works. But if instead you would be doing this just for sign out, that might be too much of an investment, and the backchannel logout might be a better alternative. OK, so now we are almost ready for the questions. Just for looking ahead, basically, I think we need just to accept the fact that this third-party cookie thing will happen and prepare. Because I assure you that the moment in which this happens, you'll start hearing people saying, this thing that used to work no longer works. And that means that if you care about single logout, which, again, a lot of people doesn't, mysteriously, but if you do care about single logout, you will have to implement some of those alternative flows. And the other part is that the non-web apps, like the tokens that we have left over in backends, or in single-page apps, or in mobile apps, also need to be taken care of. And if we keep not having a control plane for it, we'll have a problem. We have some initiatives that we are pushing with the OpenID Connect Foundation, but they don't have a lot of momentum yet. I expect that they will suddenly gain momentum the moment in which the third-party cookies will be truly gone. And now, in the classic RSA fashion, here is the advice. In the next week, as you come back and you put all the swag in the various places where you usually put the swag, you should understand what session means in your org. Is your session mostly web stuff, or do you also have a lot of programmatic access, like tokens on the back end, single-page apps, mobile apps, desktop apps? And in the first 3 months, you can actually go a bit deeper and say, OK, now I know more or less what are the artifacts. How do I move those artifacts? What's the life cycle? Do I use OpenID? Do I use SAML? Am I using homebrew stuff for which I have complete control over the code? Or am I using off-the-shelf components? And so I'm constrained by what those things can do. And so start asking questions to the people that sell you stuff, as in, what's in your roadmap? What are you going to do about this third-party cookie stuff? And then, if you have a chance, just carve little opportunities to experiment with this stuff. Like, for example, the thing about the backchannel logout, it's very neat on the slide, but once you start using it, the number and the frequencies of sign-out events are going to be significant. Like, knowing how long you need to keep those sessions in the cache is going to be very, very important. And then finally, in the longer term, you want to actually take action. As in, now you learned where you stand, you learned what is your potential path forward, and now you can actually do something about it. Oh, congratulations. You just came on time for questions. If you have questions, I'm here for you. I was making fun of my colleagues. All right, so congratulations for surviving this long on this not very light topic. If now you have questions, I'm here for you.
I have to admit to not thinking about sign out a lot myself before this presentation.
There you go. My job here is done.
I knew it was critical, but I just hadn't thought about it. I kind of assumed it took place. But given that all of this is based on the deprecation of third-party cookies, isn't single sign-on or anything related to IDP authentication at risk as well? I mean, isn't the start of the process at risk as well?
So this is a very good question. We've been working, we as in the identity community, we've been working with the browser vendors for like a few years now. And their general goal is to stop tracking. And so the third-party cookies deprecation is one of the steps that they're taking, but it's not going to be the last step. And for these, we analyze the various sign-on methods, and the only thing that is affected in terms of like the first leg is if you're trying to refresh tokens using that iframe trick. It's something that single-page apps have been doing for a while, and luckily we have a valid alternative for it. We use refresh tokens. So for the time being, we are fine. But clouds are coming, and the biggest and darkest cloud we see is a bounce tracking protection. It's going to be a measure that sees when your browser is redirected to some domain, and the domain is always the same, because one trick that trackers can use is instead of sending a third-party cookie, I'll send you on a little detour to my own domain, look at all the HTTP headers. Wait, I have to. Great, sorry.
Gorgeous.
Well, it's very fun summer for me here. So what happens is that the bounce rate, if you try to do this, then basically all the HTTP headers will tell you from where you were coming from. And so the tracker will have a dossier. And the challenge is that we do this for identity providers as well. Like you try to hit your resource, get redirected to the identity provider, and now we process your request, and we send you stuff back. The protection that we are looking at is stripping the entire request of all the query parameters that are being sent. So as you can imagine, everything will stop working. Like XAML, OpenID, everything will stop working. And the good news is that those browser people are not sociopaths. They understand that like you can't have like a critical infrastructure, like dams, electric grid is based on this stuff. So they can't just break it. And so we have like at pretty much every conference where we are together, we talk about how they can do this in a way that stops the tracking but doesn't break sign-in. So you're absolutely right to think about all the first segment as well, not just the logout. But we seem to have some leeway. And so far, I'm not super concerned. I think that given that we have the channels of communication open, and given that truly we cannot break critical infrastructure, I think that we'll do the right thing collectively.
Have they looked at utilizing TLS methodologies for doing these sorts of exchanges for the identity and for the authentication and for the sign-out, and embedding the pathing and all of those things inside the encrypted part of the packet and exchanging that, which kind of, I would think, would keep the tracking information out of the hands of a third party. They can redirect all they want, but they can't decrypt what's there.
There are historical precedents of operating at the SSL layer. There is one now dead protocol called token binding, which was used to put at the SSL layer some like special features, which had nothing to do with logout, but were very useful. And it seemed for a moment, like a magic short moment, the industry came together behind this thing. And then one day Chrome decided it wasn't worth the effort and killed their support of this. And then since then, we never attempted to try to embed anything at that level because like just too many planets needed to align in order for this to work. The closest thing you can think of for this is FIDO, in which there is like the setup in which you operate at that layer, but it's a very simple scenario and is really stateless as opposed to what we would have in here.
Thank you.
You're very welcome.
Go.
Microphone.
Come on, you go. I'll go after.
Thank you for giving us a very interesting topic. So I think one of the challenges might be the cookie structure itself, because right now the cookie only includes the RSP1 like message. How about if we redesign the cookie structure, saying in one cookie we design two cookies. One includes only the session key. We only use IDP information for that session key, and then we embed the user experience session key in that second part. Will that solve the problem, solve the single sign-out problem?
So I think that it's an interesting question, and one of the things that was discussed at the latest TPAC, which is the RSAConference, was on can we make the logout cookies special somehow?
Yeah.
And mark them saying, I promise I won't put anything of significance in there. Please treat those logout cookies as, treat them as first parties because I'm not going to use them for tracking anyway. And it's hard. It's hard because even the identifier in itself of a cookie can be used for leaking information. And in the end, the structure, what's inside of a cookie doesn't really matter if you can't get to the cookies at all. It's kind of like laws of physics versus style of how you manufacture your pottery. Like if the laws of physics makes it so that you can't get the raw material, then the content of what you are doing doesn't really matter. One big challenge we have with the browser vendors is that for them, the way of preventing this thing from being abused is to be able to observe the authentication action. As in, when you authenticate, if a browser would have a way of looking at what you're doing and saying, yeah, this is an authentication, as opposed to a tracking process, then they could give us special treatment. But this would force us to only use the authentication methods which the browsers is okay with. So today, username and password and WebAuthn. But the thing is that there are hundreds, thousands, maybe more of methods that are proprietary of whatever the identity provider wants today. And also, we want what we call permissionless innovation. As in, we want this stuff to give us building blocks so we can do our job as identity professionals and build whatever is needed. If instead we are shoehorned in username and password or WebAuthn, what happens once my mobile driving license shows up and we need to support it? So, interesting avenue of research. It's being explored, inconclusive at this point.
Okay, thank you. So my second question is, I think in your talk you mentioned if you are interested in single sign-out. So I'm just wondering, since sometimes I don't know what I am interested in or not, so I'm just asking myself, what if I do not interested in single sign-out? What if we leave this question to the individual applications? We do not handle the single sign-out. Then what's the consequences?
So I'm biased because I've been working on this for a while. So for me, the question is like, what if I'm not interested in washing my teeth before going to sleep? It's like, sure, you're free to do it, but then your teeth will rot. But in this particular case, what happens is that you can't just leave these to the applications in themselves because the identity provider needs to provide infrastructure for supporting single logout. So applications might choose not to actually do single logout. Like different vendors will have different features, but like say that your IDP is actually the IDP of one particular vendor. When you go and you register relying party 1 and relying party 2, typically you'll have something that says, I want to participate in single logout or not. And depending on the protocols that the IDP supports, you might even be able to say, and I want to use only this method rather than this other. So as a developer, people might choose not to opt in. But as an identity provider, if you don't do the work to provide at least some method, then there's nothing they can do. In other words, relying party 2, if there is no machinery like the one that I've shown during the session, to send them something when RP1 signs out, there's nothing they can do other than, I don't know, bribing the administrator of RP1, which is not very efficient.
Okay, thank you.
All right, so single logout, fun. But
I've been trying to get this working since WS Fed days, and it's not one of those great topics to talk about. So you did a great job today.
Thank you.
I guess my question is, when I think about security, what's your thoughts on continuous authentication versus single logout? Because to me, like when I just think about it as, when I hit sign out, between session takeover, between somebody leaving, especially everybody working at home, I can talk about workforce versus customer, but it's so easy to go to a website, to go to a bookmark, and as long as the IDB token is there, you're going to get in. And there's so many security issues with that. I mean, especially with like privileged or administrative accounts. But when I think about continuous auth, I look at it from a different angle. It's like it's still similar, as you can still potentially log someone out, but and make it so that there's efficient, or let's say, how the best way to say this, easier ways to still authenticate without having it be like a pop-up thing, or a MFA push. Like, we got modern technology where we can make it as, your phone is near your computer, geographically connected to your home network. I'm gonna just log you in anyway, right? I mean, just different things like that. So what's your thoughts on continuous auth as like not a replacement, but as something to augment, I guess, the single logout?
Yeah, it's a very, very good point. Like, in general, we want to preserve experience as much as we can. And today, we have a lot of arrows in our quivers to do so. As in, relying parties, IDPs can actually get as much context as they can, and they can have their own risk engines that spit out whether I want to honor an existing session or ask the user to elevate, like maybe do a little something that I think will work. And there are like a number of interesting things, like, typing DNA is like this company that tries to use the typing style as a factor. I don't think it's a full-fledged factor, but it certainly is a signal that you can use to inform these kind of decisions. I think that it's important to have the infrastructure so that when the situation is clear, you want to be able to hit the EM button and kill all the squids coming in. Like, if you want to sign out, you need a way to incontrovertibly, reliably sign out. Then, apart from those particular cases, yes, I think that having continuous authentication as a way of trying to give as much of a smooth experience as possible while retaining a good risk profile is a very good strategy.
Yeah. All right, thanks.
Thank you. And people in the back are gesturing, so I think I have to vacate the premises. Once again, thank you so much for staying despite the dryness of the topic.